Unit 3, Lesson 17 is part review, part new. We're going to be solving one-step inequalities. Okay, so this idea of inequalities is the new piece, but the steps in solving an equation and the steps in solving an inequality are exactly the same. So we want to be able to solve an inequality and then, in addition to that, graph an answer on a number line to help us understand what the answer really means. So big rule, there's two big things you need to know. First of all, it's the open versus closed rule. Okay, when you see a sign that says less than or equal to or greater than or equal to, notice the or equal to piece right there and right there. Okay, that's going to give you a closed circle. Okay, what that means is that the number is part of the solution set. Okay, when you don't have that piece and you just have a less than or, I'm sorry, I for some reason switched these. If you just have a greater than or less than sign, okay, it means you're going to have an open circle, and that means your solution, your number is not part of the solution set. Okay, maybe it's a good idea to write this down, and I'm going to ask that you put it right up here. Okay, this is less than, just in case. And what I like to tell people all the time, I'm sure you've heard this before, is it kind of looks like an L, less than. Okay, the other way is greater than. Just so that we know. Okay, alright, so there's the rule on whether or not your circle is open or closed, and then there's the really big rule, alright, which says whenever we're going to fill in the blanks here, so multiply or divide both sides by a negative number, you must flip the inequality. Okay, it's a very important rule. We're going to go over that as we go through the problems. Okay, so looking at example 1, okay, we're asked to solve each inequality in graph. So pretty simple. We're going to take a look at what's being done to the variable. This should sound very familiar to you. Ask what's being done to the variable. We're subtracting 5. Do the inverse operation. Whatever you do to one side, you do to the other side. Okay, so I end up with x, and over here I end up with 1.5. Okay, and my inequality sign is a greater than sign, and it's going to stay a greater than sign because I did not multiply both sides by a negative number or divide both sides by a negative number. Okay, now notice the graphing piece. Okay, we're going to go ahead and graph this thing on a number line. Okay, so I have 0, I have 1, I have 2. 1.5 is in between 1 and 2. Alright, notice it says greater than, it's this sign right here, and this sign goes with an open circle, because that means that is not part of the answer set. Okay, we want all the numbers that are greater than 1.5. Alright, so for example, 2 is greater than 1.5, and 3 is greater than 1.5, and 4 is greater than 1.5. So what we do is we just put an arrow going that way. All the numbers that are greater, sometimes people think the R in greater tells you to go right, whereas the L in less tells you to go left. That's another way of remembering. Alright, let's take a look at B. Now back when we did equations, we made a very strong point to not try to rewrite anything. Alright, because it's important to understand in this particular type of problem that when we go to rewrite it, we have to rewrite it the right way. We always want our variable to the left. So what I'm going to do is either at the beginning of the problem or the end of the problem, I'm going to rewrite the problem so that the variable's to the left. I'm going to do this one at the beginning. So what I'm doing is I'm taking this piece right here, let me highlight it, as one solid chunk. Okay, so it's m minus a half. So I write m minus a half exactly the way I see it. Alright, it's one giant piece. Alright, and then I'm going to put my negative 1 over here, so I'm flopping these two sides. This inequality sign is currently open to the negative 1, so I need to make sure it opens to the negative 1, because if it doesn't, then I've changed the problem. And I'm not allowed to do that. I'm rewriting it so that my variable's on the left. It makes it easier to read an inequality. Okay, so from here, I again ask myself the same question, what's being done to the variable? I'm subtracting a half, so the opposite would be to add a half. Whatever I do to one side, I do to the other side, and I have solved my inequality for m. Alright, once again we're going to go ahead and graph. So I have 0, and I have negative 1, and negative 1/2 is obviously going to be in the middle. This time you'll notice I have the line underneath it. That's my highlighter at. Right there. Okay, so that means I'm going to have a closed circle when I do this. The closed circle means negative 1/2 is part of the solution set. We'll deal more with that in class, what that means. We want the numbers less than this. Okay, less than, again, tells me to go to the left, L and L. Or, once again, if you just look at the numbers, 0 is not less than negative 1/2. So we want to go away from 0, so we're going this way. Okay? Alright, example C should be pretty straightforward. We're going to divide by 2. We get less than or equal to 8. And again, I go to graph. And, you know, you can count by 2s, by 5s, by 10s, whatever. Alright, I'm going to count by 2s here. So there's 2, 4, 6, 8. It's always good to let you know. So we're going to label it off. Okay, I have a closed circle on 8. For the same reason as the previous problem. Alright, because I have this little line underneath. That tells me I have a closed circle. Alright, and again, this is a less than sign. Less than goes to the left and includes all of these numbers. So again, what this means is when we draw this arrow, every point, every number that falls under the arrow is a solution to the inequality. For example, if I take the number 2 and put it in, 2 times 2 is 4. 4 is less than or equal to 16. And so will every other number that's under that line. Alright, let's move on. Example 2. So, in the first 3 problems, we saw practice with the open and close and just a quick review of one-step equations, basically. Now we're going to deal with this rule right here. The rule, once again, says whenever you multiply or divide both sides by a negative number, you must flip the inequality sign. So here's what happens. Example 2. Alright, we look at what's being done. We see we're multiplying by negative 4. I know the opposite is dividing, so I divide both sides by negative 4. Okay, I know what the rule is. The rule tells me that whenever the number I'm putting on both sides is negative, alright, if I'm multiplying or dividing, I have to flip my inequality sign. So this is going to flip. And I end up with a negative 9 over here. Okay. Now, you don't always have to start at 0. Alright, for example, what you could do if you want is say, okay, this is going to be negative 8, negative 9, negative 10. I have an open circle, and less than tells me to go to the left. Alright, because these are all the numbers that are less than negative 9. Okay? Now, if you didn't flip the inequality, okay, it would still be opening the other way, saying greater than. And if I, for example, take negative 8 and plug it in, negative 4 times negative 8 is positive 32. And what we end up with is 32 is greater than 36, and that is certainly not true, so we would be shading the wrong way. Alright? So this arrow, once again, shows all the numbers that will work. It's different than an equation, because when you solve an equation, there's only one possible answer. Alright, let's take a look at B. I'm going to rewrite. Again, I want my variable on the left. You can do it at the beginning or the end. I think it's best to do it at the beginning. Okay, now from here, I'm going to divide by negative 2.1. And we end up with x being greater than negative 2. Okay, again, notice, once again, the number that I'm putting on both sides that I'm dividing by is negative. So my inequality sign, which originally was a greater than, okay, was rewritten as a less than, ended up being greater than again. There's 2 reasons why it's switching. Make sure you know the difference between the 2. In the previous problem, notice again, I divide it, so I switch that sign. Okay, I probably should have used a different color up here. Alright, because that was rewritten for a different reason. Alright, let's move on. Again, I have a variable on the right. We do not want to deal with that. So very simply, I'm going to rewrite paying attention to the fact that I'm opening to the fraction, so I still need to be opening to the fraction over here. Okay, it's a different rule for flipping. Alright, that's just rewriting. Now, I'm dividing by 5. The opposite of dividing by 5 is multiplying. Keep in mind, this negative sign right here, alright, always goes with the number, so I'm actually going to multiply both sides by negative 5. Okay, so on one side, the negative 5 and negative 5 are going to divide out and become positive 1. And I have x is less than, let's see, 3.3 times 5 is going to be negative 16.5. Okay, once again, I'm going to highlight this for you. The number I'm multiplying both sides by is negative, so this symbol switches. Alright, when I go to graph it, I forgot to graph the last one, I noticed. Alright, I have negative 16.5 is in between negative 16 and negative 17. I have an open circle, and we want all the numbers less than that, so we go left on the number line for less than. I forgot to graph B, so let me take care of that now. Alright, negative 1, negative 2, negative 3. Open circle once again. This is greater than, so we're going to the right. Okay, so let's take a look at D now. In example D, we're adding 5 to the x, so I'm going to subtract 5 from both sides. Now the question is, do you think I should flip this sign? Alright, a lot of times people confuse subtracting 5 from both sides to dealing with a negative number, which is the rule that tells us to flip. It's important to understand that in this rule, okay, the two operations are multiplication and division by a negative number. It mentions nothing about subtraction. So in this case, our sign will not flip. It stays the same. Okay, and once again, graphing it on a number line, negative 10 is in between negative 9 and negative 11. We go open circle to the right. Okay, final 4 questions here deal with reading a graph, okay, reading an inequality and writing that statement. Alright, the first thing I'm going to do is I'm going to go ahead and do something that will happen first all the time. By the way, I have 2 example B's. That should be example C right here. Alright, our variable is always first. Okay, this is how we read this. When I look at this, I'm going to take the number in question, okay, and I'm going to the left, that is less than. I have an open circle, so there's no line underneath. I look at B. 0 is the number in question. I'm going to the right, so it's greater than. Again, notice the R right after the G in greater, greater, the R. It's a closed circle, so I put a line under it. So what this graph is showing right here in red are all the numbers that are greater than or equal to 0. Like 1, 2, 3, 4, and so on. Alright, take a look at C. My number in question is 7. I have a closed circle, so I know I'm going to need that. And less than goes to the left. Alright, in this one, 2.5 is my number in question. It's a closed circle, and we're going to the left again. Okay, so what you notice is, when it comes to solving an inequality, it is 100% the same as solving an equation. Okay, there's 2 little things you need to worry about, and that is if you're multiplying or dividing both sides by a negative number, you need to flip that inequality sign. Okay, and number 2, you're going to be asked to graph your answer. Alright, so you got to be worried about the open and closed circles and which direction the arrows go. If you have any questions, sign up for 1C time to get some help or ask in class. See you tomorrow.